Okay, so let's take a look at uncertainties when we have other functions besides just simple multiplication or division. We actually can develop a simple rule for exponents because essentially exponents is just repeated multiplication. So I think just by example, we'll be able to see this pretty clearly. So let's say that, for example, some calculation is equal to a squared. So in that situation, the uncertainty in this guy is going to look like this. Remember, when you do something like squaring, it means you're going to make a repeated multiplication. So essentially, it's going to be delta A plus delta A over A plus delta A over A, because this is going to be done twice. So whatever the uncertainty for A is, this guy will happen twice, and therefore I'll end up with 2 times delta A over A. But what if this thing was cubed? Let's take a look and see what that would have done. So if Q is equal to A cubed, well then delta Q over Q, the fractional uncertainty of our calculation, will be equal to delta A over A plus delta A over A plus delta A over A, and therefore that will be equal to 3 times delta A over A. So you can see, obviously, when you have an exponent like this, you're going to have the same number of these fractional uncertainties. If it's a to the fourth, there'll be 4 of these. If a to the 10th, there would be 10 of these. And so therefore, we can kind of make a generalized equation. You don't really have to do this because obviously you can see I already answered the question. But there's clearly a pattern that says that if Q is equal to a to the n power, then delta Q over Q would be equal to n times delta A over A. That's a generalized formula, and that wasn't really necessary, but it is given to you on the IB exam. Okay, and that's it as far as rules. There are no other rules that we're going to look at, but there are still a lot of other math functions that we might encounter that will have to deal with the uncertainties. So in any other situation, so for any unfamiliar math functions, we'll just use the range method. This will always work in all situations. And essentially, we already know how to do this. And so we would calculate whatever our answer is to that calculation just in the same way that we would normally do it. But then we would look for what is the highest possible value, the lowest possible value, what's the range between those two, and then that would be used to determine the uncertainty. So let me give you a concrete example. Let's say that we were looking at a situation where we had some angle, and that angle was equal to 37 degrees plus or minus 2 degrees. And let's say I wanted to do something like the sine. Now, obviously, we don't have any function or any equation right now that we could use to apply to figure out what the uncertainty for the sine is going to be. But we can always just look at the sine and take the biggest possible value and the smallest possible value, and that's exactly what we're going to do. So if you look at the sine of 37, so sine 37 equals, that is 0.6018, and I'll keep one more digit, 2. And now all I'm going to do is take the sine of 39 degrees, because that would be my biggest calculation. So the sine of 39, and that is 0.62932. 0.62932. And we'll take the sine of 35 degrees. That's 0.5735, and that last digit would be an 8. Okay, so at this point I have enough information. So let me go ahead and subtract these two numbers. That's going to be 0.62932 minus 0.57358 equals That is 0.05574. Okay, then we'll divide that by 2. Divided by 2, and now we've got our uncertainty. That is 0.02787. Okay, so that's all the math is done. We've made all of our calculations, and now it's time to put the whole answer together. So obviously you can see we have two options. I can either use the uncertainty up to this point, or we can use a double-digit uncertainty. Those are the only two acceptable possibilities. Now, if I go single-digit, this means that this is closer to 0.03 than to 0.02, so I'll drop this off, but I'll round that guy up to 3. Now, if I decide to go with 2 digits, then it's 0.027, but then of course I'm going to look at this next digit that says round up, so that would be 0.028. So my two possible answers are the sine of theta is equal to 0.60 plus or minus 0.03, and that would be in, not degrees. There's no units for this number. My apologies. Yeah, the sign has no units for it, and that would be it. Or we could also do this. The sine of theta could be equal to 0.602 plus or minus 0.028. Either one of those would be acceptable, and hopefully this helps you to see that essentially, because you know the range method, you can handle any kind of math that there is. It just might take you a little while because you might have to go through a couple of steps like this to work out what's the biggest possible answer this calculation will produce and what's the smallest possible answer. And then you just subtract, divide by 2, and you have a very accurate uncertainty, which is based on the original uncertainty of that first measurement.